going in one way, but then you quickly reverse the direction of travel for that motor, and that motor has a load put onto it, then planetary gearboxes are much more resilient to that shock that happens during that rapid reverse than compared to spur gearboxes. All right, now we go into servos. Now, there are three main servos that are currently used by FTC teams. Now, go build a servos. You have the high-tech servos, and you have the rev servos. Now, all three of these servos are a little different, although both the GoBuilder and Rev servos are pretty much similar, but it's mostly the high-tech servos that are different from these two. So first thing you want to keep in mind is tooth. Basically what the tooth count means is how many teeth are on these little splines right here. Now, this is important for determining what kind of hubs or such you can actually attach on these servos, since different hubs are manufactured with a different number of teeth. Both GoBuilder and Rev servos are 25 tooth, while the high-tech servos are 24 tooth. Another thing to keep in mind is range of motion. This basically means how much or what's the amount of range that these servos can actually turn or move. Once again, both GoBuilder and Rev are similar in which they both have a range of 280 degrees. While high-tech servos, since high-tech provides a whole plethora of different servos, can range from 120 degrees to 200 degrees for their range in motion. Now, technically, servos are basically motors, but they're just smaller. But the main benefit of them is that while motors do provide much more torque than servos, servos are mainly used for their precision. Servos can move much more precisely than compared to motors. So that's why you have motors usually used for tasks that you need more torque, while servos are usually used for tasks when you need more precision. Now we go on to wheels. For wheels, there are a couple things that you need to know. One is the diameter of the wheels. You have diameter ranging from 2 inches to 6 inches. Of course, there are larger wheel diameters. However, these are the main diameters that are used in FTC. There are also different types of wheels as well. You have Mecanum wheels, which are special in the fact that they have these rollers on them so the benefit of having these rollers is that then Mecanum wheels can do much more directional control, such as they can go sideworking and even go diagonal as well. You have heavy duty wheels, which are usually used for if you have heavy loads. You have Omni wheels, which are sort of like the Mecanum wheels, in which they have little rollers in addition to the wheel. However, for Omni wheels, these wheels are mainly just there to, if you want to move your robot to the side, then the Omni wheel won't create any friction. However, it is not like Mecanum, in which Mecanum can actually side work. Omni wheel needs a separate mechanism for it to actually allow the robot to side work. And then you have compliance wheels, which compliance wheels are a bit squishy or they're basically compliant a little, which then allows them to deform. And these wheels are usually used for intakes where you want to have a little bit of compliance to allow things in without having them getting stuck. And there are different hardnesses, from green being the least hardest to blue being the most hardest or least easiest to squish. And then you have stealth, which are wheels that basically have a rubber lining but have a hard center. So they're sort of like compliance wheels in the material that is used to have build their outside, except this time these are not compliant. These are very hard and you can't really squish them. And then you have tread slash links motion, and basically for like tank treads or tracks, you connect them and then you can drive them using one sprocket. And yeah. Now we go into how to mount these actual wheels. There are two main different types. The first one, which we are going to talk in this slide, is direct mounting. And basically, direct mounting is where you directly mount the motor shaft or your motor to your wheel with a hub. For mounting your wheel onto the axle, you usually use a hub. Hubs are basically these metal parts right here that connect your wheel with your axle. There are two main different types of hubs. You have set screw hubs and you have clamping hubs. Set screw hubs use a set screw right here. These first two hubs are set screw hubs. They use a set screw to tighten your hub onto the axle or onto your motor shaft. Now, the main issue with the set screw, or there's two main issues. One of them is that these set screws can come loose, and once they come loose, you don't have a a tight fit with your wheel and your motor anymore. So one way that you can fix this issue is that you can use Loctite to lock in the screw to lock in the set screw into the hub. But another issue with set screw hubs are that they can deform the axle if you tighten too hard. When you tighten too hard with the set screw digs into the axle and it can deform the axle to a point that your axle becomes very damaged and you can't actually use that axle anymore. The preferred hub is the clamping hub. The clamping hub basically uses a screw to clamp down on the hub instead, which gets rid of the chance of your screw causing damage to the axle. However, if when you're using a clamping hub, you can only use 3 of them, as you can see, because if you used a fourth one and tightened it right here, then the hub can't actually clamp down on the axle anymore. So when you're using the clamping hub, be sure to remember that to use only 3 screws instead of 4. Now, the second way of mounting wheels is indirect drive. Indirect drive is basically what it sounds like. You're indirectly mounting the motor to your wheel. So a couple ways you can do this is either with gears. As you can see on this picture right here, the motor is indirectly mounted to the wheel. We have these 2 bevel gears right here that are that are basically making this an indirect mount. Another way you can indirectly mount motors or mount wheels is chains and sprockets. As you can see here, we have a chain here that is indirectly mounting the motor, which is right here, with our wheel right here. Now we move on to axles. These are the main axle sizes that we use in FTC. We have 4.7 millimeter, which are axles that are from Tetrix. We have 6 millimeter axles, which 6 millimeter is the size of motor shafts, and also robotics providers such as AndyMark or Actobotics provide 6 millimeter axles. And then you have quarter-inch axles, which robot providers do make mountings for quarter-inch, but usually these are the quarter-inch is usually used in wheel modules. Now, also different axles have different shapes. The most common one in FTC are the D shaft, where you have an axle, but you also have a flat part cut to it, so it kind of resembles a D. These axles are mostly from Actobotics and GoBuilda. And then the other other shapes include round, which is basically what it sounds like. It's just a round axle, which is mostly provided by Tetrix. And then you also have hex axles, which are used by Rev mostly. So now we go into gears. In FTC, the gears that we mostly use are 32 pitch gears. And there are different types of gears. The first one are hub mount gears. These gears use or need a hub to mount them onto some sort of axle or shaft. And then you have servo gears, which are essentially the same. However, they're specifically designed to mount onto servos. Bevel gears are a type of gear that allows you to transfer your rotational force from one angle to or from one direction to another in a 90-degree angle. And these two gears, rack gears and pinion gears, work together. Rack gears are like this long black piece right here. That is your rack gear. And then your pinion gear is what is going to be driving that rack and pinion. These two gears are part of a rack and pinion. And then worm gears are also sort of like bevel gears. They allow you to transfer your rotational force from one direction to another. However, this time it uses a sort of an auger to transfer your energy. Now, one important thing to keep in mind is to make sure that your gear meshing is correct. You don't want to have your gear mesh to be too loose or too tight. If your gear meshing is too loose, then that could make you run the risk of wearing down gear teeth, and then in the end you could break your gear teeth. If you have your gears too tight, however, then that can cause problems as well, in that you can start grinding in, then your two gears could start grinding into each other and also damaging each other as well. So you want to make sure that your gear meshing is correct and that your gears are neither too loose nor are they too tight. All right, so now let's talk about gear ratios. The concept of a gear ratio is that you're basically dividing the number of teeth of your driven gear by the number of teeth of your driving gear, or the gear that is connected to your power source, either a servo or a motor. Now, the main thing you want to keep in mind, or why gear ratios are important, is that lower gear ratios provide you with more speed but less torque, and higher gear ratios provide you with more torque, however, less speed. So for an example, we have two examples right here. Let's say our drive gear right here is the gear that's being attached to our motor. Basically, Our drive gear right here has 20 teeth, while our gear that is being driven has 30 teeth. The gear ratio here would be 2 to 3. In this other example right here, we have the same drive gear right here, 20 teeth. However, this gear right here is 40 teeth. So then our gear ratio will be 1 to 2. Now, if we go to what's the effect of a higher and a lower gear ratio, then we can conclude that this gear ratio right here will provide a higher speed, but this gear ratio right here will provide more torque than compared to this gear ratio. Now we finally move on to sprockets and chains. Now in FTC, we mostly use 1/4-inch pitch sprockets, these sprockets down here. Now there are also two different types of sprockets. You have hub mount sprockets, which require a hub to attach onto your axle. And also you have servo sprockets, which are specifically designed to attach onto servos. Now, once again, sprockets are similar to gears in the fact that they are affected by ratio. Once again, a lower gear ratio means that you will have more speed but less torque, and a higher gear ratio means that you will have more torque but less speed. So keep that in mind when you are running different sprockets with each other. And all of these sprockets use these number 25 1/4-inch chains. These are going to be the chains that you're going to use for all of these sprockets, as long as it's the 1/4-inch pitch sprockets. And with that, we are done with the presentation. Thank you for listening. If you have any questions, you can email us at tobertech@gmail.com. And also, if you want any extra resources for hardware, then you can go to Game Manual 0.